Conditions. So I opened the same project we were working on in the previous lecture, and here I will create a new folder, my company, templates, and here I will make a new folder and call it conditions. And in this folder I create a new C# script. So this time let's make a turn upside down condition. So for example, if you want to your trainee to turn something upside down, for example, to turn the beer mug upside down to show that it was used, if it is bartender training, or maybe if you want your trainee to put up road cones in the correct position. So in this case, turn upside down behavior condition would find its use. So let's call it turn upside down condition and open it in our favorite IDE. So while it's loading, let's make a quick recap of the previous lesson. So as I was saying, when we enter the step, first of all we execute all activating process of the behaviors. Then we check for conditions, and afterwards we check for deactivation. So how do we check for condition? First of all, we have to inherit from condition class, and just like the behavior, it has a generic parameter of the data which it should use. So let's make another public class, and let's make it nested and call it again entity data, condition data. So let's reference it here and implement missing members. So just like with behavior data, we got our metadata and we got our name, but also we have a new property which is boolean and which is called isCompleted. Again, just a simple getter and setter. So for this property, I will talk about it in a moment. For now, it should be a simple property, so like no logic in getter, no logic in setter. And also, let's set a default name and call it object turned upside down. So let's jump to the process. And so yeah, is completed boolean. So it's a flag which the step checks in every frame, and once this flag is set to true and is completed flags of all other conditions are set to true as well, then it will proceed to deactivating phase and it will proceed to the next step. So what is important here is that this flag is checked only in the active process. So let's make a private class, private master class for our active process. And it's a process over our entity data. So similar to behaviors, we have our constructor which passes the instance of the data to base constructor. Then we have our start method, and I'd say that we don't really need to implement anything here, right? Because like all the logic we will perform during the update. So nothing else. So update. What should we do? So first of all, let's make a cycle. And this cycle will contain the check for object turned upside down. So obviously we will need a reference to that object. So let's say public training object reference. No, scene object reference. Target object. Get sets, and let's mark it as data member. And also we have to mark everything as data contracts. Yep, we don't need any attributes over these three methods because attributes are already defined in the interface. What's left we can call we can change the display name. So object to check. So let's get back to our update class. So here one more thing. So like we could do it naively and check for the exact rotation, but it would be very frustrating and confusing because in VR it's practically impossible to uh, interact with the object in such a way so you would hit a direct line. So let's make another property in our data. So this property will be a threshold. So for example, if we have an object pointing down, we can define how far it can actually go uh, slightly offset, so slightly rotating, so we would register that it's turned upside down anyway. So public float threshold. I hope I typed it right. So get sets. Again, it should be a data member, and display name it would be the same. So why bother? And yeah, also we need a default value for scene object reference. So by default, until we drop something into the field of this reference, it will reference to null, and it would be a faulty training, and designer would have to fix it. But that's their problem. So Yep, check. So what can we do? We can get target objects data target objects game objects value game objects transform rotation. So vector free angle so this means get the rotation of the transform and get the vector which is rotated by that rotation from the vector up. So if our rotation now points down, our vector up, the top of the object, will be pointing down as well. So the second vector that we want to check is vector 3 down. And while this angle is more than our data threshold, we just wait for the next frame. And once it's actually happens, so the difference between these two vectors is less than threshold, it means that our object is upside down, so we set data is completed to true and stop iterating. So there is a little bit confusing point about the Innoactive Creator. So here uh, we suppose that you check for conditions until they are complete, and afterwards we don't check for them anymore. Because otherwise it would get quite weird edge cases. So for example, if you put an object inside the bucket and step starts deactivating, and then you pull object outside of the bucket, so what do you do now? Like, you can't revert the deactivation. So like the simplest way for us to do this was to simply ignore these cases. Yeah. So once you put something to somewhere, yeah, the condition is complete and we don't bother about it anymore. So for the end, we don't have to do anything. And fast forward, for most of the conditions, fast forward will be set to wouldn't do anything. So, but conditions are a bit specific case. So consider that we have uh, so the whole idea of fast forwarding is that we try to simulate the real circumstances, so like the natural way of completing things. So for example, if we have our so for behaviors, like we have move object behavior and we want to move object from point A to point B. So we just set it to the final destination when we fast forward the step. So it's a rather simple case because like when we enter the step, all the behaviors they will finish their activation and deactivation. So there is no way around it. But consider the case now with conditions. So first of all, let's consider a step with just one transition and some conditions in it. So like normally, if we would proceed to the next step, we would assume that all conditions are fulfilled. So when we fast forward the step, we have to fulfill this conditions automatically. But now consider a step with two transitions. So one transition is taken when we fast forward the step, and the other transition is taken when we is not taken, right? So in this transition, we could have some steps which shouldn't be complete. So for example, if we have one single ball and we have two transitions and each has a condition, put it either into the left bucket or into the right bucket. Yeah, so normal execution would be choose one bucket, put it in there, then proceed to this transition. Yeah, but when we fast forwarding it, again, we have to choose only one transition. We can't complete both of them. So getting back to conditions, like in some cases, we want to complete the condition uh, when we fast forward the step, and in other cases, we don't want to do it. So fast forward method of the active process is always called, and in most of the cases, it doesn't make much sense for conditions. Instead we have so-called autocompleters. So private class autocompleter over our entity data. So again, we are missing some members here. Constructor, just like in the process, it just passes the data to the base constructor, and we have the complete method. And in this method, we simulate the completion of the condition. Yeah, only in these cases where we have to fast forward, but we have to complete this condition anyway. So what do we do here? Well, we take our target object and we get its transform, and we set its data. No, its rotation. Yeah, and we set its rotation to quaternion. Uh, quaternion LR. So LR basically rotates the object around an axis. So in this case, we have XYZ, I believe. So if we want, if we will turn it, no, yeah. So if we will turn it around the Y-axis, it would mean that it will turn around like this. And if we rotate it over any of the two other angles, it will turn upside down. And that's exactly what we need. So what do we do here? We set the rotation of the object to whatever value we need. So in this case, it will be turn around the axis by 180 degrees. Now we have to override some methods. So first of all, we want to get active process, and we will return a new active process, and we pass the data there. And the same for get autocompleted property. So we return a new instance of autocompleter. So now let's check our condition. For that, let's get back to Unity and in the configuration, let's open our old course and slightly modify it. So I will add another step in between, and in the step, in the transition folder, tab, right, menu item. So conditions, new folder, editor, and here let's create a new script. Turn upside down condition menu item. And it's very similar to the menu item of the behavior. So yeah, there it is. So let's inherit from menu item, and this time it will be not I behavior but I condition. And we don't need these methods. So for display name, let's call it my company is turned upside down. And for the methods, just return a new instance of turn upside down condition. So let it compile. And yeah, we got our condition. So object to check is the same cube. And threshold, let's say 45 degrees. And let's give it a try. So what should happen when I launch the application and when I turn this cube upside down, it should grow in size. Because if you remember the other step, the second step is rescaling the object. So what do I do here? So we got our rotation, and let's rotate it around x axis. So we turn it upside down, upside down, upside down. Yeah, so it triggered around this value, which is about right. So 135 plus 45 is 180, and 180 is uh, upside down for sure. So that was on the conditions. So let's recap it. Obviously, we have to have a menu item for that. Menu items are just the same as for the behaviors. And here we have to implement our entity data, which should inherit from a condition data. And here we have some values that that are defined in the interface, and we got our own properties, which is target object and threshold. And then we have our active process, and in this process we check for the rotation, and then we set data is completed to true, and afterwards step will notice it and it will continue its execution. But also, instead of just fast forwarding it, we have our autocompleters, which we use when we want to skip the step. Yeah, for example, you can skip the step if you use our default template. So there is a trainer overlay, and in this overlay there is a skip button, skip step button. So what else? Also, instead of implementing this whole process, you could instead implement process over base active process over completable. So here, all you have to do is to check if completed. So let's copy this condition, and yeah, we still need the constructor. And in this method, let's just return true if the inverted condition is triggered. Yeah, because before we were checking like if we should wait for the next step, and now we do it the other way around. We check if it's completed as the method name suggests. So this process does exactly the same as the process that we have written in the beginning. So even if we go to the parent class, yeah, it's the same, right? We check for inverted condition, and if it's we check for condition, and if it's not true, we wait for a frame, and otherwise we set data to true. Oh, and also if you don't want to use this process by some reason, let's undo my changes and get back to the older version of this. So in the start you have to set data is completed to false. Otherwise it will just, so for example, if you have loop and you enter the same step again and again, it will just see that it's completed and we never reset it, so it will just end up in the endless loop. I think it's not the case in the latest versions. I think we do it by ourselves now, but let's be safe right now and just set it to false just in case. So let's actually check for it. So again, the beauty of the creator, one of its beauties is that it's open source, so you can always check our source code and see what happens in there, which I will do right now. So completable property, and also let's filter by write access. So we reset it for transitions. Also we reset it in the utility class that I have just shown you. And I believe that's it. So yeah, I was right. So if you want to implement the process, instead of implementing the base active process over completable, you will have to reset this flag on your own. Otherwise, don't bother. Yeah, you just have one method, which is check if completed, and you have to implement only this. So I guess that's all on the conditions part. Thank you for your attention.